No one's here. About half the class. You only got half the class.
All right, let's get started. First, an announcement. So, UGSAC is an undergraduate student advisory committee. In any event, they're holding an event tomorrow called Get to Know a Professor. And it's just a way to go and have donuts or something. There's usually sweets to eat. And Professor Stutzman is the subject of getting to know tomorrow. And it's 3:30 p.m. in MEB 3147 if you're interested. Okay, so we have graded the midterms, as you know, and posted the grades. The average was just under 80, which is better than last year, so that's great. We'll be returning the midterms in the discussion sections tomorrow, and the TAs will be going over the solutions. So as they go over the solutions, you'll have your exam, and some of you are going to have the experience of seeing the correct answer marked wrong, because we make mistakes. So this is how you deal with that problem. If you think a mistake was made grading your exam, it can be we added the points wrong, or we counted something wrong we shouldn't have. On the back of the exam, it's a blank sheet of paper. The last page is blank. Write your issue there. So just explain why you think we made a mistake, and don't write anywhere else in the exam. Don't go and mark where you wrote the answer, and then give it back to me.
Well, what problem number? Problem number.
Yeah, be sure you say problem 8, blah blah blah, whatever, and then give it back to me, and I need to get it back by this time next week, and then I will look them over and change grades as appropriate. Okay? We're not gonna, you can ask us, if you want to ask a TA, do you think this is right or not? That's fine, but they're not going to regrade it for you, and I won't either on the spot. I do it when I can calmly reflect on it instead of when I'm arguing with a student. That's never a pleasant thing. Okay? You have an assignment out, PS7, and it's due Thursday, so we're sort of back on the assignment due every Thursday pattern. Any questions or problems about anything before we proceed? Yeah?
Do you have an idea of how many assignments are left so that we can gauge how many of our passes we can use?
5, isn't it?
I think 5.
7, 8, 9, 10, 11.
Yeah, the final project is 12. So I guess 7, 8, 9, 10, 11. And then the final project. I don't know if that sounds right or not.
I think it's 11.
You can look in the syllabus. Any other questions? Okay. Well, it's been a long time since I introduced the idea of classes, implementing classes, because of fall break and because of the exam week. So let's try to remember what we were doing. So here we have what we were doing. Sorry about this, I already remember. We were implementing a new class called MyList. So the idea was, suppose there weren't array lists already in Java, which there weren't until someone implemented them. How would we make something like an array list occur? How would you implement it? And so to do that, we had to leave the realm of static methods and change our focus to implementing classes containing constructors and non-static methods. So here we have one of the first examples we started working on. So let me just remind you, we have to, if you're trying to create a new type of data, a new kind of data, you've got to create a class whose name is the new type name you want. So when it says public class MyList, that means that you can declare variables of type MyList now. So you're defining a new type. Anytime you define a new class, you're defining a new type. And it's a reference type. You can declare variables of that type. You can pass those variables as parameters to methods. So it's just like MyList is built in at this point. Anytime you've used a class in the past, like ArrayList or like random or like string, you've had to know how to construct new objects, and you've had to know how to invoke methods on existing objects. And that's what it shows here in this main method. It's just there to show you, well, how do you create a new list? You call the list constructor. So MyList has to provide a constructor to create new MyList objects. So you can see those first two lines in main create a MyList that's referred to by list 1 and a different MyList that's referred to by list 2. Then there are methods I define on MyList. I define a method called add that adds something to the end of a MyList. I have a method called get, which gives you back the elements stored at a specific index. A method called set, which changes the value at a specific index. A method called size that returns the size of a MyList, and a method called remove that takes the last element off. Right? So it's just like, you know, you could imagine something like this being built into Java. And essentially this is a subset of ArrayList. The big difference between this and ArrayList is this can only contain ints the way we've defined it. Now, if you hover the mouse over MyList, what pops up is, it says, tells you what a MyList is, a simple dynamic list of integers. A MyList contains 0 or more integers, blah, blah, blah. Where did that come from? Javadoc. It didn't come from Oracle. It didn't come from the system library. It came from Javadoc. That's the answer to one of the questions on the midterm. The stuff that pops up comes because someone wrote Javadoc when they created the class. Okay? So it says that. And we can say, okay, what's the constructor do? And we hover the mouse and it says creates an empty list. Okay? Nothing much more to say. Hover it over add. It says appends an element to the end of this list. And so on. Now, how do we make these methods work like they're supposed to? What's the trick? How do you implement a class full of these methods? They sort of have to cooperate. Who remembers the key? Yeah. He said it have to access fields. Basically, you have to, every time the MyList constructor is called, a new object is created. That object contains within it places to store the data associated with the list. So once you have specified, once you know what your methods and your constructors are supposed to do, then you have to design the representation. So let me just scroll through here. Here we have MyList being declared. Here we have, I'll skip all that. Here we have the get method with its specification. Here we have set with its specification. We have add here. We have size here. We have remove right here. We wrote all this code last time. So we specify out all the methods that we want to have. Then we have to decide, what do I need inside each MyList object so I can keep track of the elements, keep track of the integers that have been added. And we decided last time that we needed two things. We needed one thing actually, in this case. And there it is. We need an array of integers. The idea being, if the list contains, let's say we've created an empty list and we've inserted 3 and then 6 and then 9. We've got to keep track of the 3 and the 6 and the 9 somewhere. That little bit of code says every object that you create shall contain an array. And let's see what else it says. Holds the element of the list. Is exactly the same length as the list. And the element I of the list is stored in the element I of the array. Okay, very straightforward. So if you were to create a whole bunch of lists and then look inside them, you would find arrays. So let's do that. I'm going to set a breakpoint right here. Although, I'd rather just set it right here. Let me. And I'm going to run up to that point. And up here, it's going to be hard to see because this text isn't magnified. You see list 1 and list 2. Okay, because over here, the main method, this is the stack frame for the main method. It has args, which is this parameter, and then it has list 1 and list 2. Now, if I look inside of list 1, if I expand it here, what am I going to find inside? Yeah?
An array.
We'll have an array. And in fact, what will the array be called? Yeah? Okay, be called data, it says right there. So let's cut open list 1, and there's a data array. Let's cut open list 2. There's a different data array. How do I know they're different? Yeah?
The ID numbers are different.
The ID numbers. This is list 23, that one there is list 21, so they're different lists. Now, what numbers does this array contain? If we look inside it, there's what we just did. And remember, the idea is the code is written so that whatever elements of the list are stored directly in the array. So what should we find in list 1? In list 1's data element? Yeah?
8, 20, 25.
Well, let's see. 15 has been replaced with 8. So yeah, element 0 is going to be an 8 because originally it was a 15 and we turned it to an 8. So 8, then 20 was added, and then 25. So I ought to see 8, 20, and 25. So let's look inside, and there they are. 8, 20, and 25 have been put there. And what's going to be in list 2's data? Let's see. We added a 7, and then we added a 9. And that's all we did. So there ought to be those two numbers, 7 and 9. Okay? So the code, let me go back up here. This, whatever instance variables you declare, and instance variables are just variables that are declared inside the class. They should be private. That's best practice, is to make them private. That determines what is inside the object. And then exactly how this is used is up to the methods down below. So they got to use that data in order to keep track of the elements in the list. All right, so that sort of sets the stage. And what's left is to look at the individual implementations of the list. Let's see what questions you have before I do that. Yeah?
Why did list 2 dot remove at the end, not remove the 9?
Oh, because I set the breakpoint at it, not after it. So yeah, the element wasn't removed from list 2 yet because I hadn't executed that when I hit the breakpoint. Yeah?
Why is data private again? I know it's a good practice, but why?
Okay, so that's an important question. I'll have more to talk about. The question was, why is the data private? And the fundamental reason data is private, that instance variables are private, is so you can change them. Okay? That was a question on the final last year. What is the fundamental reason why instance variables are private? The answer is so you can change them, you being the person in charge of maintaining the class. If you make them public, people are going to write code that depends on the fact that there's an instance variable called data. And then you're stuck. You have a hard time ever changing it. Keeping it private, it can only be seen from inside the class. So if you decide my implementation is crap, I want to replace it with a better representation, you can without screwing anyone else up. Yeah?
Is there something in the header of a
An empty list has length 0, and if it's got to be represented by an empty array, it's going to have to be an empty array is, I mean, if it's going to be represented by an array, the array will have to be empty. So this is something we wrote. We got to hold ourselves to this. This is our representation plan. This is very important documentation. I mean, it might say, holds the elements of the list. The first element is 0, just because, and then come the rest of the elements of the list. Then we'd have to ignore that first element all the time. It wouldn't be a very good choice. But this, the comments you put before your, the Java doc you put on the instance variables, that's what I call the representation, have to describe your plan in detail. So we can tell this is correct because it says this constructor is supposed to create an empty list. What it does is it stores an empty array into data, and that's consistent with the plan. Empty array does represent an empty list. So if we execute along, so now let me take that breakpoint out. I'll put the breakpoint here. Let's run it. There's list 1. We just ran the constructor. We look inside. There's an empty list. Now, let's step into this constructor. So I'm going to step into the constructor. Now, first of all, you notice list 2 doesn't show up over here yet because we haven't executed the declaration. I'm going to step into list 2. And notice what it says right here. This is list 22, object 22. Where did that come from? Yeah?
It's the reference to the object that we just created.
Right. Up here, well, hold on. Let's look in the code here. We just created a MyList object, and it's constructor's job to fill it in, to actually make it represent an empty list. So this just got created, and it is an implicit parameter of the constructor. The constructor has access to the object that was created here, object 22. Now, if we look inside of this, what's the value of data going to be?
Whatever it was defaultly made to be.
Okay, let's look. It's null. Okay? So data was not initialized other than to give it a value of null. It's the constructor's job to give it a different value. So now we're down here executing in the constructor. First thing it does, you see data is null there, and then now data has changed. It's an empty list. And now we step out, and we're back here, and list 2 is, let me do one more step. List 2 is that object 22, which contains an empty array. So when you call the constructor, you're giving it sort of an uninitialized chunk of memory that represents the list, and the constructor's job is to fill it in. So it represents what it's supposed to represent. Okay? Now we call list1.add. So list1.add, ad's job is to add 15 to what list? This one here, list 1. We're invoking list 1 on add. So let's step into that call and see what happens. Notice list 1 right now is object 18. List 1 is object 18. So let us step into the method and let's see what parameters it has. Val. It says val is 15. Where did that come from? Where did val? Yeah.
The parameter that we passed in.
Right. It's a parameter. So val shows up because it's a parameter, and it's 15 because when we called it up here, we passed 15 as that value. Now, where are we? Add. There's also a this. Where did it come from? Yeah.
Doesn't it refer to list 1?
It refers to list 1. It refers to the object on which the method was invoked. This, inside of the method, always refers to the object on which the method was invoked. Okay? And we know it's that because right here it says this is MyList number 18. And remember, up here, if we go back to main, list 1 was object 18. So it's the one and the same object. It's a reference to the same object. So its job is to do something to that object. Now what's it going to do to that object? We've given it a list object, Right now it contains an empty array. What does this add method have to do? I want to set this up. If you are an outside observer looking at this class, you don't ever think about arrays. When you use an array list, you don't worry what's inside those array list objects. You just trust they're going to behave like they're supposed to. So if you are a client of my list class, you wouldn't be worrying about this. If you're implementing it, though, you do need to worry about it, yeah?
You have to make a new array because arrays can't grow.
Okay, so you need to make a new array because the existing array is not long enough to hold everything. So the deal is, even though this add method is a method on my list objects, the code is going to be operating on the instance variables. So it's going to be array code inside. Okay? Which object's instance variables is it operating on? See, it's easy to get fooled. You say, okay, data is declared up in the class. You think that data refers to this variable right here. That's wrong. Why is it wrong to say that this data here refers to this data here? All right, go ahead.
Because each time you create a new object, you're creating a new data.
Right. He said each time you create a new object, it contains its own data instance. So if you have 100 objects, you have 100 data arrays. So when you want to say, on which data is this operating, what's the answer? It's operating on this's data. And what is this? The object on which the method was invoked. 8 words. Okay? And I can prove that to you. This is often called the implicit parameter. It is a parameter. It shows up there in the parameter list. And I can say this dot data if I want to. That makes it more explicit. You're referring to the data field, the data instance of this, the object in which the method was invoked. And that's the way of fully spelling it out. In fact, I could just keep going here. Every one of these things I could qualify with this. This is data. And you can see why, instead of being an explicit parameter, it is an implicit parameter, because people will get tired of doing this dot all the time. So the convention is, if you just name an instance variable in a method, it refers to that instance variable in the object in which that method was invoked. Okay, so let's see what it's doing. So right now we have an empty array. So this up here contains an array 20, which is empty. So what do we have to do? Our list just grew by 1, so what are we going to do to make it so it works? Yeah? Okay, he said reassign data. Basically, an empty array is no good. We need an array of length 1 so we can store val in it. A list with one element is going to internally contain an array with one element. So we got this handy method called arrays.copyof, and it says take this array and copy its contents into a new array that's that long. Okay, so it takes the array of length 0 and creates a new array of length 1 and copies every element from the empty array into that. Well, the new array, there'll be no elements copied in this case. So it just creates an array that's one longer. And then what do we do down here? Yeah?
You just set it equal to the array position, or the array index that you just created. It's going to be equal to val.
Okay, so we store val in the last spot in that new array. Yeah?
I have a question. So before you store val into that index, what would it equal 0 or would it equal null?
Well, right now data is an empty array. It's not null, it's an empty array. So let's step over this thing. What's going to change when I step over this assignment here? What's going to change on the screen up here?
This is
Data here right now is object 20 as an empty array. It's going to be replaced by an array of length 1. So watch it. I'll step over that. And data just got changed to array 30. And it contains a 0 at element 0. The next thing we do is we store val there, which was what, 15, I think? And then we return. And now, list 1 has been changed. List 1 now contains something different than before that contains a 15. Yeah.
So then, does the array still exist at like ID 20? Like
Okay, he's asking what happens to the array 20. Yeah?
Didn't you say it stays there for a while and then deletes itself when it hasn't been used?
Yeah, so it's now garbage because no variable in the program is referring to it. So it's just sitting in memory with no use. And Java is what's called a garbage collected language. So what that means is you don't have to do anything special. Sometime in the future, when Java needs more memory, it'll stop what it's doing, make a pass through memory, and find all the garbage and get rid of it to open up new free memory. Now, there are other languages like C++ that aren't like that. In C and C++, when you're through with memory, you've got to delete it explicitly. You got to say, I'm done with it, and you delete it. And that opens up a new kind of bug, which is you either forget to delete something and you're out of memory, or you delete something too soon, and that causes your program to crash. So that's why garbage collected languages came along later. Yeah.
So anytime we use add or remove, it's going to get a new ID, the array list?
Yeah, I basically think of ID as being the memory location. It's not the real memory location because that would be a big long number. So it's just an abstract memory location. Right, so every time you say new anything, it's going to be a unique ID for it. Yeah?
So is it impossible to have resource leaks in Java?
He asked, is it impossible to have resource leaks in Java? It's not impossible because, at least, it's certainly possible to have, if the resource leaks is open file descriptors, you can have those in Java if you don't use try with resources. You can write your code in such a way that nothing ever becomes garbage. If you maintain a reference somewhere to every piece of memory you've ever allocated, it'll never be garbage collected. You've got to cooperate to the extent that you sever all ties to your garbage. Okay, now we're going to add something to list 2. Same thing will happen. I'll just skip over it now. Right now, cut open list 2. It contains data. It contains an empty array number 23. How will that change when I step over this add, when I execute the add? It'll be a new array, so we'll see that our data change. So it got changed to array number 31, and it contains a 7, because add put it there. So I can just keep going along here. Let me expand this up. Okay, I'm going to skip over list 1.add20. What's going to change? What's going to get highlighted in yellow? Yeah?
The data with ID 30, I'll change.
Right. Data array 30 is going to change to something else, 32. And now you see the array contains 15 and 20. And now we're going to add a 9 to list 2 to make this bigger still. There it is. Then I'm going to add 25 to list 1. I'm going to go get what's at location 0. I'm going to change what's at location 0 of list 1, get list 2 size, and finally I'm going to remove something from list 2. So your clients are seeing all these operations as list operations. You are coding them as array operations. You're trying to make your list look like a list and quack like a list. That's the key. It's the mindset you have to have. When you implement a class, it's not like you implement the constructor, forget about it, implement the get method, forget about it. They have to cooperate. They have to be using the same strategy. If the add method decides to add things in reverse order so that the most recently added things are at the beginning, and the get method assumes the opposite, your methods aren't going to work correctly. So all your methods and your constructor have to be aware. You have to be aware of the overall representation strategy when you code. You have to make that plan first. I see students fall down on that all the time. They realize they have to declare some instance variables, but they don't think clearly about how those instance variables are going to be used. Yeah?
So I had a question about ID for data.
Uh-huh.
So each time, does ID store a address for the real memory location of the individual?
No, okay, he's asking about ID. ID is just an Eclipse thing. Eclipse knows the actual memory location where this array is stored.
Okay, so it's like a pointer in an abstract
Yeah,
sense.
yeah, yeah.
Actually.
But rather than display, memory on this computer is, 16 gigabytes. So rather than store, some huge number, rather than display some huge number, it converts it to a more user-friendly thing,
Okay,
right?
thanks.
It's easier to see that, okay, 20 changed to 30. It's a little bit harder if it's, a 10-digit number. Right, well, let's look at some other methods. There was our constructor. Here's the get method, okay? Pretty simple. It's told to get the element at index 5, let's say, and it just looks into the array data and finds what's at index 5, because we have a very simple representation. A list of length 5 is represented using an array of length 5. Now, what if there is no element 5 in the array? Meaning there is no element 5 in the list. What's going to happen? Yeah?
You catch the index element exception.
Well, he said we catch the exception. No, we don't catch it. We let it propagate. So if there is no index 5 in the list, there'll be no index 5 in the array. This will cause an array index out of bounds exception. We don't catch it, we let it propagate, because get is supposed to throw that exception if the index is invalid. So we sort of get the exception for free. Okay? Here's set. It just goes into the array to the specified index and changes the value to val. Yeah?
In that method where you let it propagate, like where you said you let the error propagate, you can also add throws to the header, right? Or is that?
No, you don't have to say throws array index out of bounds exception, because that's not a checked exception.
Okay.
You're only required to put throws up here if it's something like IO exception. Run-of-the-mill exceptions, it's not necessary. Yeah.
So then does the user of the class that we've created see the error then, or is that only within the MyList class?
Well, no, we'll see it. If we come up here to main, and let's say right here at set, we say change index 10 so that it's an 8. So that ought to throw in an exception. So I'll run the code, and we see we got an array index out of bounds exception that was thrown on line 61, but I just lost the window. Let me run it again. But it was also showed up on line 24 of main. So yeah, we see it there. We could catch it there if we wanted to, but since we didn't catch it, it made the main crash. Yes?
So is it better to use try and catch with the main method rather than the specific methods like set?
Well,
or
what determines that we just let the exception propagate here? Or put another way, why aren't we catching the exception in set? Yeah?
Because it already throws the kind of exception that we wanted to, so we don't need to.
Well, it's convenient that the same exception thrown by the array is also thrown by the list, but it's not essential. Yeah?
I mean, do we not catch it because we put it in the Java doc that?
Right. We don't catch it because it says if the array index is invalid, we throw an exception. It's our job. That's what we said we would do. If the index is bad, we'll throw an exception. That's how you know you used a bad index. Now, the design could be different. We could say if you, imagine we could change this to Boolean, and we'll say, okay, if the index was good, we'll return true. If the index was bad, we'll return false. In that case, you'd have to catch the exception and return false. But that's not what we said we would do. We said we would throw the exception. And so one way to throw the exception is just let it propagate. Yeah?
If you wanted to throw a different kind of exception for if that occurs, then you have to catch the.
Right. Suppose I said there's also something called index out of bounds exception. So if I had said right here, if the index is invalid, throws an index out of bounds exception, one way we could have done it is to put a try around this, catch the array index out of bounds exception, and in the catch, throw an index out of bounds exception.
Because that's on the assignment.
Yeah. Another thing we could do is just test the index and make sure it's good before we try to use it. There's lots of ways to do the same thing. So we looked at add. Here is size. The size of a list is just the size of its internal data array. And to remove an element from the list, well, if it's empty, we throw an exception. Otherwise, what's happening here? Yeah?
We're making a copy of the array and then we're removing the last element.
All right, so we're copying the existing array into a new one that's one smaller. And so the last element of the old array doesn't get copied in that case. And that becomes the new data array. So the array is changing. Okay? Yeah?
How could you make it get rid of the first element instead of the last? If you want.
Okay, let's think about that. He asked, suppose remove was supposed to remove the first element and not the last. Yeah?
On the first one, would you put data plus 1 in the first parameter?
Well, data plus 1 won't work because we're not using C++. It wouldn't be as convenient. Okay? It turns out, let's say this is our array here, and we want to get rid of the first element. Getting rid of the last one's easy because we use array copy. We would just have to allocate a new array that's not quite as big, and then copy this element to here, this element to there, and so on. Unless there's a copy out variant I'm not aware of that will do what we really want. We just have to code a little harder. We have to do the copying ourselves. So create a new array that's one shorter and copy everything there. Now, what I want to do is I got another piece of code here called list timer. And all it does is it creates an empty list, adds 100,000 numbers to it, and we time how long it takes. So right here, I'm finding out the current time in nanoseconds. And then here I find out the current time in nanoseconds, and I compute the difference, divide by 1,000,000,000, and that's how many seconds elapse. So how long do you think it'll take for this timing? How long will the timing take? What do you think? How long does it take to add 100,000 elements to my list?
Probably a while.
A while.
I'm guessing it's not going to be very efficient.
Yeah. Well, I'll tell you, you're correct. It will take a while.
It'll keep getting bigger and bigger.
Where's it going to spend most of its time?
Creating new things.
Copying arrays. Every time you add an element, it's got to copy an array, and those arrays keep getting bigger and bigger and bigger. So let's run it and see. Okay, it took 4 seconds. Okay? Could we do better? Well, let's see how Java's done. So we'll just comment this out. So we'll do exactly the same thing, except we'll time the Java's array list. So our my list took 4.1 seconds. Let's see how long Java's array list takes. Okay? 0.0069 seconds. Quite a bit faster. So evidently, they've got a better implementation than we do. Okay? We'll look at that, but I want to show you something else. Here's a my list. You may remember when we did this 3 weeks ago, someone sitting over there suggested we represent a list using a string. So the idea would be, if the list contains 7, 8, 9, we would store 7, 8, 9 in a string. If you had to add an element, you would just append it to the existing string. What would it take to find out what's stored at a given index? If that was our internal representation, we had a string. Yeah?
We just split the string
You could split the string using the split method, or you could read the string into a scanner and just do next token, next token, next token until you got to the right one. There are various ways to do it. So this afternoon I finished the implementation of that, and I don't want to spend a lot of time on it because it's not, it's not the world's best implementation. But you'll see right here, to get an element out, I have to open a scanner and then keep doing next int until I find the one I want. This one also has a timer. So let's see how long strings take as opposed to arrays. You think it'll be faster or slower than list 2, the one that we just looked at? Well, I'll run it. We can debate whether it's faster or slower while we wait for it to finish. Now, it can be kind of scary sometimes when you do this because you don't know how long it's going to take. But I timed it for a class. And it's supposed to take 16 seconds. And I think 16 seconds is about up. No, it's going to take longer because we're live streaming the lecture. There we go, 24 seconds. All right. Yeah.
So that's just that's doing this right here.
Yeah.
The stream.
Yeah. So here's the thing. Suppose that's the first version you implemented. And you've sold it. You've got lots of people using your class in their code. And they start complaining it's too slow. So what you do is you take your existing class, you get rid of your current lousy representation, you replace it with a new one using arrays, you re-implement your method in the constructor, and you give it back to your client. Say, okay, use this. And the cool thing is, nothing about the class has changed from their point of view, except the speed. But in terms of how their program uses it, the class is named the same, the constructor is the same, all the methods have the same name, all the methods take the same parameters. All that's changed besides the code is what? The instance variables, and they're private. That's why it's so important to keep these things private. So because their code cannot possibly depend on the name of the instance variable or the type of the instance variables because it's private. And so they'll be able to take out your old implementation, put in the new one, it's plug compatible with all of their code. Yeah?
So if we had forgotten to make that private and had it as public, we wouldn't have been able to go through and change them?
Well, if we had made the instance variable public, that means that of all of our clients, some of them are surely have noticed this public instance variable and have probably written code that makes use of it. Because that's what people do. If it's in the interface, they'll use it. It would show up in the Java doc. So they may say, I'm not going to pay the cost of calling add, or of calling set to get an element out. I'll just go directly into the array to get index 5 out. That'll be faster. And that's great until you give them a class with completely different representation. And suddenly their code breaks. But it's your fault. Because you should not put the instance variable to be public. Because then clients start depending on it. You make it private so you can change your mind later. Okay? But list 2 is lousy as well. It took 6 seconds, better than the string version. So what should we do? Make it better. Yeah. Let's try again. So let's take a break and we'll look at list 3.
Just adding something to it.
array with an empty list with an array of length 2. Now it turns out that when we do that, Java will store zeros in both places. Now we store, let's say, a 7. And someone comes along and says, okay, how big is the list? How big is the list at that point? It's of size 1. We've only added one element to the list. The array, though, is of length 2. The array is bigger than the list it represents. How will we know to say 1 instead of 2? And I think his answer, did you answer right?
Yeah.
Was essentially we say, okay, that's uninitialized. What's the problem with saying, okay, there's only one non-zero element, therefore the list is of length 1? Yeah?
The user might try to store 0.
Right. Maybe someone comes along and says, okay, store 0 in the list, and we store it there. Okay? At this point, we want to say the length is 2. So what do?
Well, we could have a private variable that keeps track of the number of items we have in there, add to it when we call add, and subtract from it when we call
Exactly right. You're not limited to only having one instance variable. You can have as many as you need. So I have 2 up here. Notice I have, my first instance variable is count. It's the number of elements in this list. Okay? Not the number of elements in the array that's contained inside the list. The number of elements that are in the list. The number of adds minus the number of removes that have happened, if you will. So when we first create this list, the list, data will look like that. And count will be 0. What happens when we add a 7? How will this change when we add a 7? Right? We'll put a 7 here, and the count will go up. If someone says, how big is the list? We say 1. If someone says, what's in element 1 of the list? We throw an exception. Even though there is an element in the array, we still got to throw an exception because it's not in the list. Now someone adds a 2. And this changes to a 2. So far, so good. What happens when someone adds another element? We need to make it bigger. We used to make it 1 bigger. Our new strategy is we're going to make it twice as big. So we'll go from having 2 elements to having 4. And when that fills up, we'll go to 8. When that fills up, we'll go to 16. Okay? So the copying becomes less and less common. Okay? The time between copies is getting further and further, and the copies are getting more expensive, so it sort of evens out. We're doing it less frequently, but each copy costs more. It turns out you save a huge amount of time doing this instead of just growing by 1 each time. And that's how ArrayList implemented. I don't believe they exactly double the length, but maybe 40% longer or something for obscure reasons. Yeah?
Previously, when you were adding things to it, I don't know how many, like 1,000 times or something, wouldn't say, for example, at the 900th element, say if we need to copy it again, would you have like a lot of just empty values?
Oh yeah.
In the size?
So at any given time, when we first, if there's 1,000 things in the array and we have to double it, we're going to double it, add one more element. We're going to have almost 1,000 elements empty. So we're wasting space. Now we could have just said, okay, to heck with this. Let's just make the element 1 billion elements long to begin with and hope that no one will do that many adds. Well, the problem with that is you're spending, 4 billion bytes of memory to represent an empty array. So if your program creates 1,000 empty arrays, suddenly it's out of memory. So this strategy, empty arrays are represented with small things, and as the list gets bigger, empty lists are represented with small arrays. As the list gets bigger, so does the array. Yeah?
If you ask it what's at one of the later indexes that hasn't been sent yet, why would it give you an error instead of...
Well, okay, so he's saying, suppose that we double it, we've added 5, and now someone says, what's at index 3? Well, we have to write our code so that it can't rely on the array throwing an exception. So let's code this up and see if we can improve on our speed. So notice, these are very essential, these comments here. So count is the number of elements in the list. Okay? And data, it says the elements in this list are stored So that whatever list this represents, they're stored in data 0 through data of count -1. And the length of the data array can be bigger than that. And we could write more. Probably ought to. But this is the strategy you have to keep in mind. So to create an empty list, how do we do that? What does the constructor have to do? It has to set the instance variables so that they stand for an empty list. Yeah?
You could set data equal to a new int array of size 2.
All right, I decided I would have at least 2 elements to start with. So we'll use a 2-element array. What else do we have to do? Yeah?
Count equals 0.
Right. Great. So whatever object is being initialized as a MyList, it's going to have its count field set to 0. It's going to have its data field set to an array of length 2. Yeah?
Why would you initialize it there instead of in count? Your private in count.
Yeah, typically, yeah, you want to, we want to, rather than come up with a philosophical argument, the constructor is the place to initialize instance variables. User ought to be able to go, the programmer ought to be able to go and see what you do with the instance variables right there. Okay.
There may be more than one constructor.
There can be more than one constructor, Stefan just pointed out, yeah. Just like you can overload methods, you can have multiple methods with the same name, you can have multiple constructors as long as they take different parameters. We'll see that eventually. Now here's the get method. Now I've written part of it. It says if the index is less than 0 or it's greater than or equal to count, then we throw the exception. Okay, so we just check up front. We can't depend on the array to throw an exception for us because the array could be longer, could be twice as long as the list it represents. All right, once we're sure that the index is good, how do we return the proper value from the list? What do we return instead of 0? Yeah?
Return data with the square brackets index.
Right. We return element index, just like we did before. Okay. Array, yay long, only part of it actually matters. The first count elements matter. As long as the index is in there, we're good. We just go pull the element out and return it. Okay? What about set? Again, I'm making sure the index is in bounds, not by looking at data.length, but by looking at count. So what does set have to do to change what is stored? Set is supposed to change what's stored in a specific location of a list. How do we do that? Yeah?
You could do data of index is equal to val.
Yeah. Essentially the same thing we were doing before with our old representation. The only difference is we have to explicitly count, we have to explicitly check the index bounds. All right, add. That's going to be something different. Let's skip that for now. How do you, if someone asks what's the length of the list, what do you tell them?
Count.
Count. We've got that nice variable to tell us. Now we got remove and add. So let's think about, remove. How do we remove an element? What would be the simplest way possible to remove an element from the list? Yeah?
Couldn't we just decrement count by 1?
Exactly.
We shouldn't even need to change the array.
We don't need to we don't need to change the array at all. So let's suppose that we have an array. Say our list contains 7254, which means count is 4, and someone says remove the last element. So we just say okay. We leave data alone. Now, surely someone objects to this. It just seems wrong because we're trying to get rid of that 4, and yet it is still there. Nevertheless, this is correct. So how does that work? We didn't get rid of anything. Yeah?
Well, when we try to, if someone was to try to get an item at that index, our get method, it would see that count's too low for us to have that value, so it would never go there.
Right.
If we try to add another on top of it, the 4 will just be overwritten.
So that 4 is sitting there, but there's no way for the user to get at it. If the user tries to access element 3 of the list, it's going to, our code's going to throw an exception. The index is too big. So there's no harm. We could change the 4 to a 0 or something, but this is basically just room to grow. Only the first 3 elements matter. Now, I can think of another objection to this, which would be you create a million element array and then you remove everything from it. And what would you end up with besides a count of 0? So, yeah, say that a little louder.
A lot of memory used for no reason.
Right. You end up with several megabytes of memory to represent an empty list, which seems kind of extravagant. So maybe you want to make it so that, I could imagine if the array gets too small, if it gets less than half full, maybe at that point you want to copy it to a smaller array. I'm not sure what array list does. We're just going to live with it. So the internal array will be at least as big as the list has ever been. So that's really easy coding. Now there is one problem here. There is a bug with this, I just realized.
Wonderful.
You can't remove from an empty list, right? So we have to say something like, let me copy so I don't have to type so much. We've got to throw an array index out of bounds exception if the list is empty. So what condition do I put in here? Yeah?
Count less than 0?
Well, if count is equal to 0. Count should never become negative. So if the list is already empty, we throw an exception. Otherwise, we decrement count. Cool. That just leaves add up here. Yeah?
We just set the one at index count and then increment it?
Okay, so we would like to do something like that. We'd like to say data sub count equals val, because if there are 4 elements in the array, what's the next unused spot in the array? 4 elements in the array, that means those 4 elements are in data 0, 1, 2, and 3. So the next element should be element number 5 is at index 4. So that works. Then we have to increment count. Okay, so data count sub val stores in the next unused element of the array. Then we increment count, but what?
We haven't changed the size of the array if it gets full.
Right. If it's full, we're going to have a problem. So suppose this is a situation. Count is 3. Someone says add 7. So we'll go to data sub 3, 0, 1, 2, 3. We'll put our 7 there. We'll increment count. Now someone says stick 5 into the array. It will try to put it here. That's an invalid index. So if the array is full, then we got to do the copying operation. Well, how do we know if the array is full? Yeah.
I was going to say, couldn't you just do a try catch? And then if you catch like an
We
index.
could. Yeah, he said, could we do a try catch? We could, but I choose not to.
Count is equal to the length of the user.
Right. So if count equals data.length, what is it we want to do?
Expand the list.
Good grief. Okay. We got to do that copying operation, which is something like arrays dot copy of, and we want to copy from data. And how long do we want the new array to be? Twice as big as it is now. So that will grow it appropriately. So if it's already full, we make it twice as big. Oh, that's not going to work because it returns an array. I got to store it. And at that, then we can do the last 2 lines, secure in the knowledge that our array is big enough at that point. Cool. Now, let's see if we did this right. So I have a test suite right here, my list test. So let's run all those tests and see if, okay, so we pass all the tests. But now the interesting question is, have we improved the efficiency? Okay, so how long did the string one take? Like
24 seconds.
Yeah, long time. How about the original array one? 6 seconds? What about the array list? 0.006. Okay, we got all that down. So let's go here to my list, the list timer here. All right, it's doing all the right stuff. Let's see how long it takes. How can that be faster than Java?
You're just that good, Joe.
It's a miracle. I gotta rerun this here. All right. Well, great. I could try to explain why, but I'd just be making stuff up. The only thing that occurs to me is I know that Java switched from doubling the length to going about 40% some time ago to improve memory usage. Maybe that cuts down on the roll speed. Or maybe there's just something else wrong with it. The important thing is not the comparison to array lists. It's to compare the original data version to this version. I mean, how many times faster is it? We went from 6 to, okay, that time, from 6 seconds to 3,000th of a second. So that's like 3 orders of magnitude, over 1,000 times faster. So that's a huge payoff. And again, that's an illustration of how classes can evolve. You implement a class, you decide to make it more efficient. And you're able to do that because instance variables are private. Yeah?
I was wondering, wouldn't it be, why would it not be a better idea to, instead of doubling it, like add 100 every time? Wouldn't that be better for memory-wise?
Well, it might be better memory-wise. Let's try it out. That's the cool thing. We can just try it out. So I'm going to go to my list here. Wrong one. Is it running the right timer? Okay, okay. I think I was running a timer down here. Let's go here and try it out. So what will we have to change about the program? Just once it fills up, make it 100 bigger. Right. Instead of doing 2 times count, we would do 100 plus count. Let's try it as idea. So we'll run it. Not run that, we run a list timer. It's about 10 times slower. More than 10 times slower. Okay? So this is the sort of thing you get into in 2420, is understanding how this happens, being able to predict. When you're really good at this, you can just predict that it's not going to be as fast. But it's, empirically we can see. Now let's try this. Let's go back to our implementation, and I'll go back to what we had. I'm going to change the constructor so that instead of getting room for 2, I'm going to make it have room for 100,000 elements. All right, that's all we're inserting, right?
I don't think you deleted the plus down there, add.
We'll make it 100,000. I'll make it 100,001 just to be sure I'm not off by 1. So we're going to make the array as big as it ever needs to be, but of course, generally we wouldn't know how big it is. And then we're going to run it. Okay. So it's that way. It's a little tricky to get accurate measurements. That's pretty consistently known. But it's not making much difference, is it? It's probably faster. But it does pay the cost. It has to allocate that huge array to start with. All right, I want to put this back the way it was, so when you look at it, it will be correct. So we'll put this back at 2. Now, I want to show you something else. Well, first I'll see if there are any last questions I can answer about this. Yeah?
So what changed about this last one is we started using arrays?
No. What changed about the last one is instead of creating a 2-element array to represent an empty list, I created one that was 100,001 elements long.
Well, I mean, as far as the one that was a lot faster compared to...
What made this a lot faster was that doubling strategy. Make it twice as big when it fills up. That made it just a massive difference. Yeah?
For this string representation for the MyList, would it be faster to use like a string builder?
He's asking about ways to optimize the string representation, maybe by using a string builder. Yeah, possibly, but it's fundamentally not going to be competitive no matter what you do. Okay. Now, let me show you where I'm headed. I'm going to give you a history lesson. So, this style of programming that we're looking at here, this is where object-oriented programming got its name. The first person to realize, one of the first researchers to realize that languages needed to have some way of keeping representations private, like we talked about here, was in 1967 with a language called Semula. So if you've ever seen Pascal, which is another language, Semula was a version of Pascal that first introduced the idea of classes. But it wasn't until, there was a lot of research in the 70s, but not really until the beginning of the 80s, where languages that provided for private representations in common use. C++ was one of the first that was widely adopted. And that's what you mean when you talk about object-oriented programming. So the part of class up to today, not up to today, but through the midterm, that midterm that you had last week could have been a midterm in class I took in the 70s. Except the language, if you change the language, I wasn't using Java, but the kinds of questions that were asked in there could have been asked about the language I was using. But the stuff that we've done since then would have been completely unknown to people like students like me in the 70s, because these ideas all came along later. So I'm going to show you how this stuff like this was done in the old days. So we're going to take that doubling representation, and now here's my mylist.java. Now this is not how Java is intended to be used. But back in the old days, what we would have done is we would have recognized, okay, we got to keep track of a list. I want to have an array, and I want to have a count. That's the length. And so I've created something up here. In the old days, it would have been like a struct or a record, were words that were used for it. But we would create, there was no notion of public or private, so basically everything was public. So we would have defined something like that. Just a chunk of memory, an object, we didn't call it an object, that contains count and data, and they're public. But what's missing here? Besides these instance variables, another word we weren't using, being private,
there's no methods.
There are no methods to go along with it. So, sort of in the old style, we would have defined mylist that way, just saying structurally what a mylist was, with no notion of making this private. And then we would write a bunch of static methods to manipulate it. So I want to look at this is the main method. I had to modify everything. So what I do is I just created a method called construct, and it returns a mylist object that represents an empty list. And then what happened to all the calls of add? What did I change there? Yeah?
You had to mention the object as well, because it's not an implicit parameter anymore.
Right. So instead of saying list1.add and having list1 be the implicit parameter, add now takes the list to add to as an explicit parameter. Okay? This was the old style. So all these methods are static. You don't invoke them on objects. You pass the object you want to manipulate as the first parameter, explicitly. So here's the construct method has to create one of these mylist objects, fill out the instance variables, and return it. Okay? The code is very similar. If we take out this piece and take out this piece, and change list to this, then it's the same as before. Okay? Here is the get method. Rather than operating on an implicit parameter, we pass in, we say, find me what's stored at the given index of this list right here. And it works just like before, but instead of looking at this.data, it looks at list.data. So everything that was an explicit parameter before, everything that was implicit is now an actual parameter you have to pass in. We do the same thing with set, same thing with add. So to add to a mylist, to add a value to a mylist, you see if lists count is the same as list.data.length, we do the copy of it, and then we store in the proper location. So the methods are implemented in a very similar fashion. The big difference is there's no implicit parameter. So that's how we would code. But what problems do you think this led to? What is it about this stuff here that led to the adoption of sort of modern object-oriented techniques, so information hiding, keeping the representation private? Yeah?
There's something changed about my list. People who've used my list in the past and after the change.
Yeah. So what the idea was, if my list changes, if I decide, okay, I'm going to change how I represent my list to make it work better, then yeah, I'll have to change all the men directly on count and data. So in the old days, the idea was, okay, here is the representation, here are some methods, these are the only ways you're allowed to enter. Yeah, you'd expect it to be about the same. Let's see if it is. So we'll run list timer on this version here, so it's using that, so let's run it. 0.004, 0.006, 0.004, 0.004. Okay, we'll call it 0.004, slightly close to 0.003. Now we'll come to this one. Same as before, 0.00. What do you think? It strikes me as being slightly slower. Okay, just eyeballing it. I mean, I could do a more careful timing. But it turns out that when languages went from the strategy I just showed you in version 4 to a strategy like version 3 where information is hidden, where instance variables are private, there's a small amount, because of the way languages are implemented, there's a small amount of execution overhead. It makes programs slightly slower. It's not necessarily it doesn't necessarily have anything to do with information hiding. It has something more to do with inheritance, which we'll talk about later. And predictably, anytime a new programming strategy is adopted, people will go say, well, you can guarantee people, will be a chorus of people saying, but it's slower now. You've made the language slower. Now, it's not much slower. It's very subtle. But the reason people are making these changes is to make programmers more productive. So, and these changes have always won out. If you can find a way to create a language that makes programmers so they can create programs faster and more reliably, even at the cost of a little bit of execution speed, it's well worth it. Computers keep getting faster and faster. It's not clear that programmers keep getting better and better. It's the tools that get better and better. So raw speed isn't the way we judge languages anymore. It's how well are they tuned to the needs of programmers. Okay? So we'll stop there. We'll look at more examples next time. You need to get going on your assignment.
If anybody left anything in here, do you guys